I see some familiar faces, some new faces. So very nice to meet you here and welcome you here. And now without further ado, I'd say, let me introduce the first speaker to you. So we have two speakers. Talks will be about 25 minutes. You can ask your questions afterwards. Also for the people online, write your questions in the Q&A chat, and then I make sure we read them out loud and the speakers can answer them. And yeah, for the first talk, I have David with me here, a colleague of mine at DeepSet working on Haystack. He's an expert in all these different kind of advanced retrieval techniques and will tell us more about it. I think it's so thorough, it could even be like a survey paper at some conference. And if you listen carefully, you might get a few hints here and there for a challenge we run in December, the advent of Haystack. So there will be a challenge specifically also about one of the retrieval techniques that David presents today. And yeah, feel free to participate then next month. Now with that, the stage is yours, David.
Okay. Hello, good evening. Thank you, everyone. Thank you for being here. Also, hello, everyone who's online. I'll be the first speaker. And this is the first slide, as Julian mentioned, is the advent of Haystack. You have some challenges to do. There's a challenge coming every day or every second day. Feel free to have a look. It's fun, especially if you want to know Haystack. But anyway, going to my presentation, I will talk about retrieving with Haystack. That will be the main focus of my presentation, and retrieving in the context of RAG, of a retrieval augmented generation system. This is the overview of how a RAG system works, the architecture. So you have a query or a user question that goes into a retriever. The retriever is connected with your knowledge base of documents, and it will retrieve documents, snippets of text, which then are composed together with the query to go into a prompt. That prompt is then fed into an LLM, which ideally will use the context extracted from the documents and the question to answer to the query or the question that you want to know something about. But for today, we're just going to focus on one of these components, the retriever. Let's go a bit more deep and see what's inside the retriever. Typically, the baseline retrieval method works in the following way. You have your document, you split it into chunks, and then we index those chunks. And then during query time, you pass a user query into the vector database or the document store, depending on how you store the chunks of your documents. And then you retrieve the ones that match your query, either by computing some embedding similarity with your query or by filtering by keyword. And then you present those to the user by ranking them. And the typical approach is to rank by similarity with the query. And this is like the baseline. This is almost of all RAG systems at the beginning start with this retrieval approach. This is the first thing that you can build and gives good results. But maybe we can make something much more out of this simple approach. And this is the main outline for the talk. I will firstly present some classic retrieval techniques, many of them coming from the information retrieval days. I will present some of the new proposed LLM-based retrieval techniques. I will do a comparative summary, and then I will just present results of a small experiment I did with all these with all these retrieval techniques. So starting with the classical techniques, I will present 4 of them. Let's go into the first one, sentence window retrieval. As I showed in the first slide, this is the vanilla baseline retrieval approach. And in this case, the user query returns from the document stores 3 chunks, the chunk 1, 8, and 5. But the idea of the sentence window retrieval is that you can retrieve chunks before and after the matching chunk or chunks so that you can get more context. So in this case, what you will do, instead of returning only the 1, 8, and 5, you would return the 2, the 7, the 9, also the 4th and the 6. So this would be a simple way to gather much more context about the chunks that matched. And the only prerequisite, which is something not very expensive, is that when you index your chunks, you need to preserve the order, so that when you retrieve chunk number 8, you need to know exactly which chunks are before that one and after that one, in the way that belonging to the document which was chunked. So you need to keep that order. But it's the first one, sentence window retrieval. Let's go to the next one, auto-merging retrieval. So here you have a different way of structuring how the document goes into the document store. The first thing that you have to do is you have to structure your documents in a hierarchical tree structure. You can do this in many ways depending on the type of documents that you have, but for illustration purposes, let's say that you first split your document into paragraphs, and then each paragraph you split it into sentences. And then the idea is that you're going to use all these sentences, or at the leaf nodes at the bottom of this tree, you use them for indexing and retrieval. Then the idea behind this approach is whenever you have a user query, it will only match the leaf nodes at the bottom of the tree. But the idea is that you set the threshold, and whenever you have leaf nodes from a paragraph, let's say in this case, that match more than a certain threshold, instead of returning each individual sentence in this case, you return the whole paragraph. This will be a way to get more information than the individual chunks from each of the paragraphs. So in this case, if we set a threshold of 0.5, and if the first paragraph you get 4 sentences that match, you immediately return the paragraph plus the sentence from the paragraph 2, which was also matched in the query. One downside, not downside, but one thing on this approach is you need to index these documents in this. You have to first split them in this structure and then index them in this way. But yeah, this is one more way to doing this. Let's check one more approach. This is, well, it's still within the domain of retrieval, but this is more of a re-ranking approach. I kind of packed everything, different ways of indexing, re-ranking, and retrieval. I packed all inside the word retrieval, but let's see it. So as I said earlier, the classic retrieval technique will rank the documents based on the similarity that they have with the user query. But maybe you want to do something a bit more elaborate. Let's say you have you have multiple news sources that are reporting on an event, something that is just happening, and new developments occur, and every news source is reporting about it. And you have access to all these news sources. Probably what you want to do is you don't want to retrieve everything related to that topic that's already been retrieved, that you get repeated descriptions of the same event. You want to have the next development on this event, the next thing that follows this narrative. So the idea here is this is a way to also to rank, taking into consideration how novel is this document based on the documents that you already retrieved. So this is a formula to rank the documents that takes in consideration the query and the documents that you already retrieved. And they can be ranked by this formula. So the idea here is that you have a query, you have already 10 or 5 documents retrieved, and then you want to order these 10 or 5 by how much they are relevant to the query, but novel to the ones that you already retrieved. Let's just break down the formula in a simple way. Let's look at this first part in square brackets. So the first term, given you want to rank it, you have one query and you have the first document that you want to rank. So in this case, you compare it the similarity with the query, and then you compare it with the similarity of the already selected documents. In the first iteration of this, this will be 0 because you don't have any selected documents. But let's say this is already the 4th iteration. So you'll compute what is the maximum similarity of the document you are considering towards all of the documents that you already selected. And you want to max this because you have a minus sign there before. So this will penalize documents that are very similar to the ones that you already have. So you have these two terms, one to weight with the query and the other one to weight similarity towards, negative similarity towards the ones that you already selected. You have also the lambda parameter there, which essentially is just something like a knob, just to say I want more weight to the similarity to the query, or I want more weight for the novelty towards the selected ones. And outside of the formula, you have the argmax, so that you just want to do this for all the ones that were still not selected. But essentially, this formula says that the goal is that a document should be relevant to the user's query and have minimal similarity to the previously selected documents. It's a way to rank by novelty. This is one way to rank the documents. I also included in the retrieval, but this is one re-ranking formula. So let's see one more, the last one from the classic, hybrid retrieval and re-ranking. This is a simple approach. I'm sure many of you are familiar with two ways of dealing with text. So I guess until 2012, 13, everything was single words, and each word was unique. Well, still unique, but it was represented by very large vectors, with each vector represented how much weight a word has in the document. The BOEM25 and TF-IDF vectors. You can still use these approaches, and these approaches work more as a keyword-based filtering towards documents. So the idea is you have a retrieval system that works in this way, and you have another one that works with embeddings. And the idea is that when the user query appears, you query both databases with the different approaches, and you have chunks from different from the different databases. Then what you can do, you can also re-rank the chunks, and you have this rank. Like, I guess one good example of the use this, imagine these e-commerce platforms where some customers they already know exactly which product they are looking for, so they will type the name of the brand or the model, and you get the documents that relate to that product. Others will make just more a textual description, and for that, it's better to have the embeddings to match. That could be one potential use case of these approaches. And with this, we are done with the classic retrieval methods. Let's have a look more into the ones that now use LLMs to perform retrieval. I will present three. The first one is the multi-query. So the idea here is when you see the user query, you can use an LLM to do two things with the query. You can do expansion or you can do decomposition. Expansion essentially meaning finding synonym queries related to the one that you wrote so that you can increase retrieval. LLMs are good at that. You just have a way to rephrase what you're looking for, your question, with maybe other words that are more expressive, and with that you can increase recall. One other way to use the multi-query is by decomposition. If you have a very complex, long question, you can ask the LLM to decompose it in single independent questions that later can be combined to give the answer. But so what you do after, you have one query that is transformed into multiple queries. You also can consider the original query or not, as your choice. And each query is used to make a new individual retrieval process. And that's what you do. At the end, again, you can choose if you want, you can re-rank the documents and then present the documents to the user in a re-ranked way, or you can just present them all aggregated in a single list. It's one technique that you can use at the end, the re-ranking, if you decide so. So this is the multi-query approach. Let's see one more. So the hypothetical document embeddings. This was something recent proposed on the paper from 2022, or 23, I'm not sure. It has some similarities with the multi-query approach, but here, instead of using the LLM to generate similar queries or decompose a complex query, you will ask the LLM to generate an answer to this query in the form of a document. Well, an answer that then you can consider as being a document. Ideally, something short, not a big document, but imagine that the LLM can give three different extensions, answers to this question. And what you can do after is to embed these documents, these hypothetical documents, and you end up with one vector for each of these documents. What you do after is you take an average pool of these vectors and you you see a new vector which is made up from the 3 vectors that were initially created. And then essentially what you do is, instead of using the original user query to query the document store, what you will do is you will use this new average pulled vector from the documents generated by the LLM to query the document store. It's a simple approach, but gave good results. Imagine this can be something that can translate when someone is typing something complex in a very specific domain that maybe you don't know the vocabulary. You can have some reformulated answer that then can go more into the vocabulary of the domain. Think about medical domain, for instance. Let's see one more approach for LLM-based indexing. This is called document summary indexing. The idea here is to use the LLM again for indexing, the indexing step. And what you do here is you use an LLM to generate a summary. So you have a document. For each document on your knowledge base, you have to pass it through an LLM, and the LLM will give a summary. I'm sure here, depending on the LLM or the prompt you give, you can have a very complex summary or you can have a short summary. That's for you to decide. But the main idea is to have a summary for each of your documents from your knowledge base and to index all those summaries. Then you also do one more thing, which is what we do on mostly all of the approaches, which is to split your document into chunks and create a parallel vector database which has the chunks. So at the end you have two document stores. You have one which has the summary and you have another one which has the chunks. Then at query time, what you do is when you receive a query from the user, you first query the summary index database, and ideally this will give you a few documents, not many. The idea here is that you really narrow what you're looking for. You get the documents that are really related to your query, and you get the reference to those documents based on the summaries of the documents, and you will use this reference then to directly fetch the chunks from the documents that they refer to. And here you can then filter the chunks by similarity with the query, or you can just get all the chunks together and then select them by some other method. This is the last one, the document summary indexing. This was a lot, all of them together. Let's have a look of them in a bit of summary, also as a recap. So each one of those has different properties. So at the bottom, the last ones, they all rely on an LLM to do it. The ones at the top, they don't need LLMs. Some of them, the sentence we know, the auto merging, they only need a special index structure. The maximum margin relevance is essentially just a way of re-ranking. And you can see here that you could combine them. You can have sentence window retrieval, and then at the end you re-rank by maximum margin relevance, for instance. The hybrid retrieval, you just combine two different sources of information. Not different sources of information, different sources of indexing or structuring your information. The multi-query is essentially one way to do query rewriting, so you try to reformulate what the user is asking. The same thing for the hypothetical document embeddings. And then the document summary probably is the one that's most costly. You need a custom index. You need to combine information from different sources, and you also need to rely on an LLM for this. So this is just a kind of a wrap-up of what we see in the previous minutes. What I did after was to implement these, well, some of them are already part of the Haystack core package, others I had to implement. But I had all of those working, and I did a small experiment. So there's this data set out there called ARAGOG, Advanced RAG Output Grading, which is a data set mostly made of preprints from the archive that cover topics around transformers and LLMs. And together with that data set, there are 107 questions for which there are also answers generated by the ChatGPT, but then that the authors of the papers validated and corrected. So you have a knowledge base of documents. You have 107 questions for which the answer is on those documents, and you have those answers validated for humans. So what I did is I run these questions over each of the retrieval techniques that I just presented. And then I compared the answer generated by the LLM with the one that's part of the golden truth, the ground truth of the data set. I use the semantic answer similarity, which essentially this is, you just embed both the ground truth answer and generated answer. You see with the cosine similarity how similar they are. And then, so this was the results. This is lots of information packed in, but I have there, so for all experiments, I use the GPT-4o Mini from OpenAI. I have some specific parameters that I used for each of the retrieval techniques. For the ones that don't need any specific things, I used always the same document store. I embed everything using that sentence transformers model. The chunk size was 15, so each chunk has at least 15 sentences, and I always retrieve the top key 3. So if you look there in a bit of detail, you can see that the sentence with the retrieval, although is very simple, achieved very good results. Like it's only 3 percentage points below the best approach, which was the document summary indexing. But most of them, the scores are not very far away. But anyway, I was curious to see that even simple approaches usually give good results, not very far away from very sophisticated and costly approaches. But anyway, this was more of an ad hoc experiment. I just wanted to get hands-on on these retrieval techniques, to have them implemented and seeing them running. Of course, this needed to be like squeezed with parameters and more runs to really see what's going on here. Some error analysis. I didn't do any of that. I just wanted to see all these things working in Haystack. All the code is available there on that URL, so you can check it or play with the code if you want. And this is just a reference, so that where these retrieval techniques are. So the sentence window retrieval is on the Haystack core. Auto-merging retrieval is something on the experimental, which I already mentioned to some of you before the talk started about. The hybrid retrieval with re-ranking is also part of core. The multi-query, I implemented, but there's 2 really also nice blog posts that explain the decomposition and the expansion approaches for the multi-query. And the document summary I implemented from scratch, and is also on that repository. That's it. This is just some references that I put here, which I used for this presentation. And I leave here the last slide with the reference to the Haystack framework and to the code with the experiments. This is all. I hope you enjoyed. I'm open to questions from the crowd and also from the internet.
Well, thank you, David. I think for the online people, we best to repeat the questions, any questions that are raised here. And for everyone online, yeah, please write questions in the Q&A feature. Any questions here?
So, thank you. So I guess like at the end of the day, the retrieval technique you should choose it based on the use case. Like some use cases are very like specific keywords, which like case the keyword with the hybrid approach might be useful. Some other use cases you alluded to it with the one case of this auto merging, or if you have a lot of the first one, if you have a lot of similar documents. One retrieval is useful to use over another. Did you kind of go over the results you got for the specific particular tests, and did it kind of make sense, those numbers that you got, those final scores that you showed a few slides ago?
Okay, the question is for those at home is if I went through the results and if there is like a sense or connection between the retrieval approach and the type of data set. No, I did not. This was more ad hoc experiment. The data set I had was PDFs, preprints. Some of them have these 2 column sides, and when you pass them to text, might not be perfect. You might lose some information there. My feeling tells me that, for instance, one approach might not be the best. Like if you structure this with the auto-merging retrieval, you usually have very short sentences. And I mean, maybe you can do the auto-merging retrieval, but you split that by paragraphs of the paper. But for that, all the papers need to have more or less the same similar structure, or you need to find a quick way to identify the sections. I guess at the end, these things depend a lot on you, on the type of data you have, the use case, like what kind of people are going to use this, what kind of queries are they sending in, and how much time or money you have to try out all these different approaches, right? I guess at the end, that's what I would think about if I had to put something like this into production.
In this table, if you can go back, you used GPT-4o Mini for what exactly? For prompting after you retrieve the documents, like the parts.
Yeah.
But then that's not because the actual ground truth was made by GPT-4, right? And GPT-4 Mini is quite, I would say, weak in compared to GPT-4. That's one thing. And second thing is also, I was wondering, you are comparing the answers, right? Generated by both.
Yeah.
And that you did using cosine similarity. But I think using an LLM would be better, right? Instead of cosine similarity, it kind of depends on how good the model you are using to get the embeddings. It's just I maybe can give more accurate evaluation.
Okay.
Yeah.
So one observation was that so I used the same, well, not exactly the same, but a variation of the same LLM model on which the questions for the paper generated, and also to generate the answers. Yeah, it's true. I could have put here another LLM to use. I just used that paper because it's one of the few data sets out there that's easy to use, and I've been playing with it. So it's the baseline data set that I go for these experiments. The second question was more about, instead of using the semantic similarity to measure the results, to use an LLM. Oh, my personal opinion, I'm very skeptic about using LLMs for evaluation. I don't trust it. So if I have the ground truths, I would even maybe, if it was really like a system to go to production, given that it's only 100 questions, I would even sit down with someone else and let's see it by hand, which of the retrieval techniques does it better.
Yeah, by hand would be the best.
Yeah, using the LLM for evaluation, it's like, because you run that 100 times and only like maybe 85, 90% of the times it gives the same answer. All the others vary. And that for me makes me, I don't know, with a bit of data science background, it feels a bit weird. If you don't have any annotated data, anything, and you want to have a feeling or just a small understanding how things are, might be a good initial approach, but to make a final decision, probably I would always go for something more robust. Or combine both, yeah.
I have one question from online, from Naveen. I read it out. Thank you. What would be the ideal approach when queried on a data store to get the summary or insights? Example, if a dataset is a list of customer orders and the query is like, can you get me the orders that are pending?
Well, I imagine that if the orders are pending, you have a structured way to say that, and maybe you can do it with SQL, no?
Yeah.
That's my first feeling, but I don't know the data. I maybe when he says the orders are pending, he knows by reading the text that they are pending, and it's not in such a structured way. I don't know. You probably have to understand, like, if everything is text and you have embedded, you have to understand what query words are embedded in a way that always end up closing the space to something that's pending in the textual description. That's what I would try to look out for.
Yeah, text to SQL could be
Or
a
text to
keyword,
SQL, yeah.
which is, I mean, yeah. We have another talk later on, so let's see. Learn one more question, I think, for time reasons.
How fast or slow are them? What if these retrievers and if they make a huge difference?
Okay, the question was about efficiency of this approach. Actually, no. But when I was preparing the presentation, I remember even showing Julian, I had one extra column here, which then I removed it, which was scalability of each of one of these approaches. My feeling is that everything that needs LLM is very expensive and takes time. Like imagine for the document summary, each document that you have needs to go through an LLM and needs to have a summary of it. And then imagine that the document is so big that doesn't fit the context of the LLM. You have to do that recursively by batches and keep the summary and send the remaining of the document and do that in an iterative way. So I would say that if you want to see the baseline, to make a baseline system before trying any of these things, is go for a baseline RAG or the sentence string retrieval, something like that. And then you have a feeling. And then depends, again, money and infrastructure and time, how much you want to invest on the system, and money to spend to see how much the results go up. But for me, everything that needs the LLM, either for indexing, you need it's going to be much more expensive. And depending then if you can query the LLM in a sync way or make batches, if you can have the extreme case that you can only do one call per time to the LLM, so you have to wait and do again, that will be take loads of time.
Okay, then let's thank our speaker again, I'd say, out of time reasons. There's one more question online about papers. Maybe you can answer that in the chat.
I will. Okay.
And we need a minute, I think, to set the laptop up. So feel free to grab another drink or some small snack. David, can you share the slides? Was one question. So we will upload the video recording also on YouTube. And I think there in the video description, for example, we can link the slides. Okay. So this is for you. Is this clip on? Yeah. Okay. Just a second. It's looking. Looks very good to me. Okay, good. Okay. Can you hear me on the thing? Yeah, I can also double check, but okay, I think we're ready. Then let's start with the second talk. Next to me is Oren. Oren volunteered to give a presentation. So he messaged me, I think, a couple of weeks ago already, right? With 2 ideas what to present. And now today he will present about evaluating NLP engines and testing them out, finding bugs, going deep into what maybe we can still improve in these NLP engines. I think something is also about data augmentation, I read. So very much looking forward to your presentation. Stage is yours.
Thank you. And also definitely there were a few points from the previous presentation that are going to become very relevant to what I'm about to talk about. So I'm going to talk about NLQ-as. It's an analytic system for NLQ, which I'll explain in a second. But of course, it's going to be relevant for all kinds of NLP engines. So just quickly about me, my name is Oren Matar. I actually come from a background of social sciences. And about 8 years ago, I transitioned into data science. And I think that's a great field to transition from to data science. I think data science has a lot to learn from social sciences. I spent most of my career at Anaplan, and now I'm a freelancer consultant for AI engines. So I'm going to talk today about some of the work that I did at Anaplan. I assume most of you are not familiar with Anaplan, so let me give you a very brief introduction to what Anaplan is. So Anaplan is basically a SaaS platform that holds financial data for big firms. So think about like loads of Excel spreadsheets with all the data about like revenues, employees and their salaries, sales targets, all of that. So it's all on one place on the cloud with privacy and security and all that jazz and fun. So now that we have all of the data, and for like really big firms, all of their financial data, all of their expenses and so on in one place, this creates a huge potential for these users. Because this means that there's one place where we can query questions like, yeah, what was the revenue from soft drinks last year, if we're a company that sells soft drinks? Who's the best salesperson? How much money did we spend on servers last month? All of these are questions that now we have all the data in like one place, in one store, and we can get all of these insights theoretically instantly. The problem is that querying the data is quite difficult when you have so much data, because it's not really just one Excel spreadsheet that you can just walk in and look at it and understand what's going on. You have all of these different tables. Some of them are up to date, some are not. Maybe when you have a table referring to revenue, it's not called revenue, it's called rev or something like that, some sort of code name. So it's not very easy for everyone to query the data. So you have actually people whose expertise it is to know where everything is. But it would be really great if we could get to self-service analytics, where everyone can just ask a question, and if it's within their permissions to see this data, they can get the insight very quickly. That would be super powerful. So what we are talking about basically is NLQ, natural language query. How can we take a natural language and convert this into something like an SQL, can be any other structured language that we can use to query the data. So how can we do that? Well, I'm not going to talk about that today at all. Maybe we're going to use an LLM. That's a fine engine to use. Maybe you want to build like a rule-based engine. Maybe you want to have 1,000 employees eagerly waiting for every query that comes in and translating it at the spot. That's not what I'm going to talk about today. I'm going to talk about testing and analysis of these engines. So maybe you have several engines, could be several LLMs or different approaches, and you want to compare them. You want to know which one is the better one to use. Or maybe you have one and you want to know how well it's doing, what are its failure points, and then you can do some research and figure out what to improve in it. That's not an easy task, and sometimes I think doing really good testing and analysis to understand where your engine fails, it can be more important in a sense than getting like the best engine, because every engine has its failure points, has its weaknesses, and if you don't know what those are, you can't really improve on them, and you don't really have the transparency, and then the transparency to your users to know when it's going to fail, and then maybe you can direct them to use the system in a different way. So testing and analysis can be as important, I think, as the actual engines. So what can we do? Well, the naive answer is, okay, let's just create 100 queries by hand. I'll write the query in natural language, I'll write the SQL query, and now I can take any one of my engines, run them on these queries, and I get an accuracy score. Okay, so my LLM is 80% accurate. Okay, that's nice. That's a nice baseline, but I think it doesn't do enough justice to the idea of testing and analysis and evaluating our engine. So I think there are three main reasons why testing NLP systems is particularly hard. The first is that language is just incredibly diverse. There are so many different ways to express the same idea in different words. So it's very easy to overfit on a small data set. If you have 100 queries, maybe your LLM does very well on these, but it doesn't really cover the diversity of language. Let's just take, for example, just the element of the time extraction. So I have some query and there's something like since 2019, and I need to convert this to a specific date range. Okay, so what ways can I use to express the date range? I can use something like day, month and year in June 2018, something. I can use abbreviations, which are very common in financial terms, like Q3, the third quarter of fiscal year 20, which is not the same as calendar year. You can use relative years, like last year, 3 months from now, and so on. So you have all of these different ways to express, and this is just for the time element. You have all of these different ways that you can express the date range that you want, and it's very likely that my LLM or whatever NLP engine, maybe it's doing really well on this relative term, but not very well with the abbreviations. So I need to make sure that I actually cover the entire field, the entire diversity of the language. So that's one problem. The second is that there are no documented features. So I don't really have any documentation of the linguistic features that I support. I don't understand the distribution of language and where my LLM, or I'm going to stop saying LLM, NLP engine, whatever it is, where it's failing and in what areas, because I don't have these features. Now, what do I mean by that? Let's take a simpler case where we have tabular data. So maybe I have tabular data of apartments that were sold in Berlin. Okay, so I have like the price, and I have the number of rooms, and the neighborhood, and the size in meters square, and floor, and so on. If I have this sort of data, I can maybe train a model on this. But also, when I come to test my model, I can get a lot more insight into what is this model really doing, and where is it working? I can look at this and say, do I have all of the relevant neighborhoods in my data set? I can do like this sanity check. I can look at the distribution of the size of the apartments and see, okay, I have no apartments that are bigger than 100 meters squared. Okay, that means that my model may be really good for the data set that I have, but when I see an apartment that's bigger than that, I don't know if the model is going to fail. So I can now sort of map out where my model will likely succeed and where it is not going to succeed. And I can see maybe its accuracy is higher in one neighborhood and not in another neighborhood. I can get a sense of what's going on because I have all of these features. But with NLP, we don't really have these features. I just have the query, and I have the SQL that I need to translate to. So it's very difficult to get an understanding of where my engine is doing well and where it's doing poorly. And the last problem is if you look 20 years ago, most of NLP work was very rule-based. So people would program feature by feature the features that we want to support. Nowadays, because it's all LLMs and black box models, we don't do like unit tests for every new feature that we want to support, every linguistic structure that we want to support. So we just throw it on this black box and we kind of hope that it's going to work. So we don't have the same transparency that we had when we 20, 30 years ago actually programmed every rule by hand, and we could get a better understanding of what's going on. So those are the problems, and that's why we came up with NLQ-as, the analytic system for our NLQ problem. This is an engine agnostic system, so as I said, it can work on an LLM or any other system that is meant to find the limitations of this NLP engine and give us more transparency and basically documentation on the success of our engine and with the kind of features, the kind of linguistic challenges that it can support and where it does well. Obviously, I'm going to explain these principles as they pertain to the NLQ problem, but I think the same principles apply to many different NLP problems. So what are the principles of this NLQ systems? The first one is the automatic generation of a test set. So as I said, we can generate by hand like maybe 100 questions, but that's not enough. As we've seen, it doesn't really capture the diversity of the language. This is why we can automatically generate a much, much larger data set. Now, how can we do that? Well, if we think of what we are trying to accomplish here, we're trying to translate to SQL. Now, what are the elements of SQL, of the query that we're trying to build? Well, there's a table name, okay. There's the columns that we're trying to select revenue and profit from this table name. There's a categorical filter, maybe there's a time filter. There could be other things like a group by, aggregation function, and so on. But we can basically map out these few elements. Now, if we have these mapped out, we can sort of reverse engineer the query. So if I want to build an example automatically, what I can do is first sample one of the tables randomly. So as I said, I have a database of all of this financial data of my customers. It could be like real database or just a mock that we use for sales. But I have loads of these different tables. So I can randomly pick one of these tables. Now I can look at the columns of these tables and I can say, okay, so let's randomly pick salaries as the target column that we want to select. And let's pick a few categories from it. And let's randomly pick a time range and so on. So I can pick these different elements of the SQL query that I'm about to generate. And I can just get them randomly, sample them from the data set that I have from the database. And now that I've sampled these elements, obviously I can just take some sort of structure of a phrase with these blanks and just fill in the blanks, and I get a sentence and what is the salaries, group by role, and so on. And I put different things there for every sample that I make. And obviously I can create the SQL in very much the same way, just a different structure. And now I can easily generate a table like this with as many examples as I want of a query, these elements, and the SQL that is made from them. So basically what I'm doing here is I'm sampling from the entire space of questions, of queries that the user might be interested in, because I have all of these different revenue, sales targets, whatever, salaries. I have all of these different terms, and I'm sampling all of the questions that someone could potentially ask. Give me this column, group by that column, aggregate using a sum or something like that. I'm sampling from all of these, and I can sample as many as I want. So that's great, but there is one problem, and that is that this is kind of a very rigid way of producing these examples. So if you think about it, if I have this example here, there's a query, what was the revenue in 2020 in New York? Okay, where did the word revenue come from? So I sampled it randomly as a column name from some table. And that's why it says revenue as a column there, and that's why it's revenue in the SQL. But it has to be revenue, it has to be the same word in the SQL and in the query that I generated. Now that's not true to real life, because in real life, a user may ask what was the income, which is kind of synonymous to revenue. So my way of generating these examples doesn't generate all of the queries that the user may ask. I'm only generating a subset where, for example, I don't have these synonyms, because of this rigid way of, and sort of very structured way of generating these queries. So I'm missing a lot of the diversity of language. I'm not adding any synonyms. I'm not adding typos. I don't support lots of these difficult and complex grammatical structures. So what can I do about that? Well, the first thing that I can do is pretty easily just add those in. Like, it's not too difficult to write a piece of code that takes a query and just randomly replaces some words with it in the query with synonyms, right? It's not difficult to find like a synonym table and to find that revenue is synonymous with income or whatever. And now I can support these synonyms. Obviously typos, grammatical structures, and so on. So I can sort of I can think of the different features of language that I want to support, and one by one add a piece of code that randomly adds these features. And that's a very good solution. Of course, it is limited by my imagination. So that's good. But one thing that I can do better is use the LLM superpower. So from my experience with LLMs, they can be pretty good with maybe converting text to SQL. They can be fine with coding, but the one thing that they really never fail me with is, like you also mentioned, rephrasing. I have an email, I did not write it very well, not very good English, and I give it to an LLM, hey, can you write this in different words? And they give me an answer back, and it's rephrased and contains the same meaning, but in different words. So I can go to my favorite LLM and say, hey, here's a query, can you say the same query, but with different words? So I have the query that I generated automatically with the system. What are the salaries, group by rows, and so on. And the LLM gives me a few different queries with the same meaning. So it replaces the term group by with a breakdown, and salaries with how much were the employees earning, which is great. It's like a completely different grammatical structure and different words, but they have the same meaning. Roles is replaced with a position, and so on. So that's great. So now I can take my data set that I generated automatically, and I can take this query that I generated. I know that the meaning remained the same. So the columns that I select, the categories, the group by values, and so on, basically the SQL that I generated for that automatically generated query, that remains the same. But what I can do now is add these LLM generated queries and give them the same answer, the same SQL basically. So now I enriched my data set with a lot more. So this is where the data augmentation comes in. This is what I'm saying is that LLMs are really good for natural language data augmentation. You can take your data set and multiply it and enrich it using an LLM, so you cover more of the diversity of language. So obviously, I'm talking today only about this analysis system, this analytics system and evaluation. But as a side note, you can use the same technique if you're going to fine-tune or train any kind of model. If you have a data set, you can use an LLM, enrich it, and then if you train a model on that data set, it'll probably be a better model. Okay, great. So now I can create this huge data set. I can take any of my engines, run them on this data set, and compare the actual results with the correct SQL that I have. But that doesn't give me a lot, because now I'm just going to be looking at the results and it's, okay, so this engine has 63% accuracy and that engine has 68% accuracy. Okay, I guess I prefer the 68, but what is going on here? Like, why is it failing? Where is it failing? What are the issues in these engines? That's what I really want to know. So this leads me to the second point in this NLP analytic system, and that's building an attribute-aware test set. So what do I mean by that? Well, the first thing is that instead of scoring my engine on the SQL, I have all of these elements that I already extracted, right? So instead of just thinking of the columns and the categories and the time filter as like building blocks that I use to create the SQL, I can just score this, the accuracy of my model directly on each of these elements. Now, this already gives me a much higher resolution understanding of what's going on here, because now I can start plotting things. I can see, oh, okay, my engine is doing pretty well on the column selection. It's not doing very well on the time filtering, and it's great figuring out which aggregation function is used. Is it sum or mean or something like that? Already I have a better understanding of where it is failing, why I can start looking at these examples with a bit more insight and have and maybe try to fix these specific issues. Now, what I would also like to have is something like this. As I mentioned, we're kind of adding these synonyms automatically, right? So I have some queries that have synonyms and some queries that don't have synonyms. It would be really great if I can score the accuracy of my model for queries with synonyms and without synonyms. I can start segmenting my data set. So how can I do that? Well, that's actually pretty easy, because if I have this data set and I have these columns for categories and so on for each query, well, all I need to do is add one more column which says synonym. That's a Boolean. Are we using a synonym here? Yes or no? And now I can, I mean, this is pretty basic code that you can write and get this automatically. You just have to look at whether the word that is used in the columns, like salaries, does it appear in the query? If it appears in the query, then you're not using a synonym. If it doesn't appear in the query, then apparently you are using a synonym. So that's like a one-liner, and now I added a new feature to my table. So now I can use this feature to, again, create these sort of insights and understandings of where my engine fails, what are its weaknesses and what are its strengths. But what if I didn't have just one? What if I had loads of these attributes? What if I started creating tens of them? Am I using a synonym for the columns? Am I using a synonym for the categories? Is the query phrased as a question or just as like a command? Give me the revenue for 2020, or what is the revenues 2020? That can be a feature. That's like a linguistic feature of that query that I can have as another Boolean here. Does the time element have an abbreviation, like I said, Q2, or a relative term, like last year or 3 years from now? What is the query length? All of these are features that I can add, and basically most of them I can just write a very small piece of code that I can deduce and create this huge table of linguistic features. What have I done here? Basically, I've done what I said in the beginning that I really like about tabular data. I made natural language into tabular data. Now I have all of these features. Now I can understand the distribution of my data set, and I can see what is missing and what is not missing. And you give me something like this. I'm a data scientist, so you give me this, I'm having a good time. I'm going to start plotting things. I'm going to see, okay, what is the success rate relative to the query length? Take any one of these Booleans and see the accuracy with the Booleans. Start creating lots of features when you have two Booleans together. Like, there's so much that you can do. You give me a few hours with a data set like this, and I give you a lot of insights on which of your engine is doing better for which segment of your data set. Obviously, this is not just to score different engines, but also to get a better understanding of what you actually have in your test set. So, like I said, maybe in our apartment sales data set, I can see that I don't have any data for apartments bigger than 100 meters square. So that tells me something about the limitations of my test set, basically. That's a limitation that I should know. Here as well, maybe I can look at the number of group by values that every query has. So revenue, group by country, and region. Those are 2 group by values. So how many group by values do I have in my test set? Okay, so I have a lot of queries that where there's 1, some that 2, and I don't have any with 3. Okay, that tells me something about the limitations of my test set. And when I'm scoring my engine, what am I actually scoring it on? So when I have all of these features, and it's not very difficult to create maybe tens of them, I can get a much better understanding of the distribution of language that I'm actually looking at. Oh, before I get to that, like one last point I wanted to make. So how do I pick these features? So this is a very important point, I think. This is where the product team comes into play. Because as a data scientist, I'm good with these algorithms and plotting stuff, but I don't really know what the product team believes that the users are going to use, what kind of language we actually need to support. This is the responsibility of the product team to basically give us the specs. What do we want to support? What do we want to test and make sure that we're supporting? So this has to be with communication with them, that we figure out what are these features that I'm going to add, so I get better transparency and visibility into what I'm actually testing. And that leads me to the third point, which is creating an open dashboard. So I don't have a lot of time to discuss this in length, but basically what we did is we created a dashboard that allows anyone in the organization, they can log in and see the results of the engine and segment them in those different ways. Because if I have the data set that I just mentioned with all of these different features, I am good with pandas and Python and so on, so I can create all of these different plots very quickly. But someone who's not a coder, they can't create these plots. So basically, the only people who can understand the test set, the success rate of the engines are only the data scientists. I don't like that. What I want is to have a dashboard. So we created a dashboard. And if you've never done that, it's very easy. You can use a library like Streamlit, and within like a few hours, even if you've never done any UI work ever, I show you can create a dashboard. It's pretty straightforward. So we created this sort of dashboard where anyone, like the product team especially, can go in and they can say, okay, we have all of these different variations of engines and versions of them. They pick an engine and they say, okay, give me the examples where the query length was bigger than 10 words, and there was a synonym, and show me its success rate on extracting the time element, whatever. They can create those specific filters and whatever they're asking for, whatever they're querying, and this dashboard would give them the accuracy for that specific segment that they were asking for, and examples of queries where the engine succeeded in, and examples where it failed. And this means that there's a much more direct and easy communication between the data science team and the product team. They're not just giving us specs and then we work on the algorithm for months and we don't speak to them and then we come back to them and wait, this is not at all what we wanted. This is not the kind of queries that we were thinking users will actually use in practice. They can, at their own time, basically go in and see what are we actually testing the engines on and make sure that everything aligns and makes sense to what their plan is. So yeah, to sum up, to build this NLP analytics system, you can generate automatically a test set. Some of this can be done using simple sampling from all of the possible queries that you can make, adding some code that creates more diversity, like automatically adding these synonyms and so on. And then you can, on top of that, add an LLM to create even more diversity, and you have a pretty robust data set. Make sure that this data set is attribute aware, so it's not just a simple accuracy metric, yes or no, but I have all of these different features of the language that I can look at and get a better understanding of where it is failing and where it is not. And then if I can create an open dashboard to anyone in the organization, then I'm giving this transparency to a lot more people. And if you do all that, then you basically get documentation for the linguistic features that you support. You have clearer research directions because you know the weaknesses of your engine and therefore what we need to work on and improve. And you have more accuracy metrics. It's not just, okay, which engine do we want? The one with 63% or 68%? I have all of these different metrics. The accuracy for when you have synonyms, when you don't have synonyms, for every kind of segment that you want, and for every element of this SQL. And now the product team can have a better understanding, and they can pick the version that they want, not just by one number, but by lots of these different metrics, and get a better understanding of what they're actually choosing. So that's it. Again, my name is Oren Matar. If you want to connect, that's my LinkedIn QR. Yeah, that's it. Thank you. Yeah.
How do you make sure that the features extracted from the question matches the column names? Is it just the paraphrasing from LLM?
Again, that the features extracted from.
Let's say, what are the revenues of the year 2023? So the figures is the year and the revenue, right?
Come again? At what point are we?
Asking the question,
Yeah.
what was the revenue of the products X in 2023?
Mm-hmm.
So you get three features: product name, year, and the revenue.
Mm-hmm.
What if the column name in your SQL table is not revenue, is income?
I'm not discussing that. as I said, like I'm not going to talk about like that's obviously a big question, but you can use any engine. I'm just talking about the evaluation system. Obviously, that's something that I want to make sure that my engine can support, that I can support these synonyms. So what kind of engine am I using? Maybe I'm just using an LLM, and I hope that it figures that out. And so, you know, the most naive way to do this is to use an LLM, give it the query, and also to give it the schema of the tables that, and say, okay, this is the query. You have all of these tables, and now pick the relevant columns from these tables. And maybe you have to filter the just a subset of the relevant tables. And then you hope that the LLM works well. But like you don't know. That's why you need the evaluation system, so you can create lots of queries where supposedly, like a hypothetical user asked a question where there's a synonym, so the term used in the query is not the same as the term that is actually used in the table, and I can see how well my engine is doing. That's the point, just testing this. There's no solution, but there's only more transparency and understanding how well can I cope with that.
And as this is not today's topic, maybe it can be the topic for next time. And more questions here in the audience.
Yeah.
Congratulations. This is I find interesting idea of how to reverse these things and be more insights instead of focusing, oh, how can we improve now this LLM? My question was more about how could you potentially use these insights to improve an LLM or any other technique to, is that an open question that can you leverage this and send it to someone who works on these things on how to improve this translation?
Let's repeat the question again.
Yeah. So the question is, now that I have these insights, what can I actually do to improve things?
The engine
the engine. So, you know, obviously that kind of depends on what exactly is the engine that I'm using. Yeah, I mean, let's say I am using an LLM. And let's say that I find that, you know, it doesn't, now that I can create these insights, maybe I find that it can't, well, do I have these examples for, yeah, the diversity of language. So now I see that it doesn't cope well with these abbreviations. So it doesn't know what Q3. So when one of my questions has like, what was the revenue in Q3, the LLM doesn't do well there. So now what can you do? You can do some prompt engineering and tell the LLM, okay, you should be familiar with these abbreviations. Q something means third quarter, and FY means fiscal year. So you can just do some prompt engineering. Maybe you can do some fine tuning of this LLM with specific examples. So, you know, it depends now on what is the exact engine that you're using and what is the problem. But assuming that we can do some engineering work and And also one more thing that you can do, if you completely fail, if you don't find any way to improve your engine, and you see that you have low accuracy for, let's say, these abbreviations, that's at least something that's good to know, and maybe communicate with the users. Like you can have, I mean, now that's like a UX thing, that's not my field, but you can somehow communicate with the user the kind of questions and queries and the kind of phrasings that they're encouraged to use, so they'll be discouraged from using phrasings that my engine does not support. So yeah, once I have this transparency into what I'm actually doing well and what are my weaknesses, I can attack it from lots of different directions, depending on the specifics. Yeah. Yeah.
I was just wondering if you have really lot of tables and which are interconnected and joins, then this reverse engineering can get pretty complex. How can you generate these questions which involves 3-4 tables?
Yeah. If I start, yeah, sure. So I can say that at least for this specific, so again, let's separate like the principles of this method from like the specifics of this. Let's say that for my specific use case, it was agreed that we don't really need a lot of joins. So the assumption was that basically all of the information, any query that a user can use, is all of the information is probably in one table. So that made things easier. If you have joins, it doesn't change anything in principle. It just complicates things a little. But you know, as far as like the automatic generation, so you need to sort of have some sort of index that tells you which tables are connected, which tables can be joined because they have like an index in common, and then you can just randomly decide. Sometimes I'm going to join and ask a question about something from another table, and so on. So I can add that logic into it. It complicates things, but it doesn't change them substantially. Yeah.
So there's one question online.
Yes.
Thank you, Oren. 2 questions. First, what's your take on NoSQL specifically, JSON-based document store like Elasticsearch or MongoDB?
What's my opinion on like NoSQL? I don't have one.
And second, and if your query is to get insights from a database,
Yeah.
for example, having sales data in place, get me recommendations to improve my sales.
What?
Bit difficult to understand the question for me too. If your query is to get insights from the database, for example, having sales data in place, get me recommendations to improve my sales. So it sounds like you not just want to retrieve data from the database, but you also want to get some automatic recommendations about it. Maybe some LLM that interprets the retrieved data. Yeah.
What do you mean, like recommendations? I can take this in lots of direction.
Yeah.
Like recommendations for actions, like we did not make enough revenue from that product, so we should advertise
like
more
that
or
to me,
something
yeah.
like that.
Maybe a bit out of scope for your presentation, but maybe you have some thoughts on it too.
I don't have a lot of thoughts, no. I mean, all I can say is to put this in the scope of the presentation, I think it's important when we have those features to still develop these metrics and evaluation systems. And I see a lot of people today, it's so easy with these LLMs to forget about having a test set at all. So, well, because we don't have a training set, so we don't have a test set either. So you just build these features and you don't really know if they're doing any good. What percent of the time are they accurate? Maybe you do like manual testing for like 5 minutes and you get like the gist of it. So all of that I can say is if you want to add these features, that's fine. You know, have an LLM, look at the results of the query and give some recommendations and interpretations and suggestions for the causality of why we see this specific results and insights. That's great. But make sure that you also develop some sort of system where we have at least a few hundred examples of insights that would make sense and that would make sense, and that I can compare and I can actually test this engine and see if it's giving me any insightful insights, if it's giving me anything worth the effort. Yeah, that's all I have to say. It's a little more difficult with something you know, as vague as, you know, giving me insights. But I think that's part of the work of a data scientist. Okay, so now let's take that and break this into elements like we've done with the SQL. It's a little easier with the SQL than it is with these insights, but can we think of what kind of insights we want? Can we break them into elements? And then can we do this work and create this data sets of insight and its elements and the features and so on? If we can do something like that, we will be able to understand if our feature is doing anything and possibly, yeah, where to improve it and compare different LLMs and so on. Yeah.
Okay. If there are no more questions right now, then thanks again to you for your presentation.
Yeah.
And this concludes the presentation part of the meetup, but we have the space for some more time. So feel free to stick around, grab another snack. And for everyone online, this concludes the call. So I just close the video call. Thanks for joining and hope to see you again soon. All right.